For number 11, I would start by rewriting this before I take the derivative, so I can use the product rule. So x times x squared minus 1 to the negative fourth. When we take the derivative, we're going to have to use the product rule because we have x times this whole thing. So it's the product of two functions. Derivative of the first function is just 1 times x squared minus 1 to the negative fourth, plus first function x times the derivative of the second. So here's where we have to use the chain rule. We have negative 4 out in front, x squared minus 1 to the negative fifth. So that's taking the derivative of the exponent part, but then we have to multiply by the derivative of what's inside here, which would be 2x. So we get x squared minus 1 to the negative fourth minus 8x squared times x squared minus 1 to the negative fifth. So here we can factor out an x squared minus 1 to the lowest exponent, so that would be negative 5. If we factor that out of this first part, x squared minus 1 to the negative fourth divided by x squared minus 1 to the negative fifth. We subtract the exponents, we get x squared minus 1 to the first, or just x squared minus 1. Second part, if we divide that by x squared minus 1 to the negative fifth, those cancel out, and we just get minus 8x squared. So if we combine some like terms in here, we get negative 7x squared minus 1. So we could write our answer like this. Or if we use positive exponents, we get negative 7x squared minus 1 all over x squared minus 1 to the fifth power.